Got it. So typically you start at the vertex. Like if you know the vertex,
Yeah,
you're
you do the vertex first, and then you like do the table thing.
right, you offset from that. Okay. To find the vertex, though, we're first going to find the intercepts. So you've got to set each of these
Equal to
equal to
0.
0.
So then it would be 2, -2,
That's right. So the vertex is right between the two of those,
0.
which is at 0. And then we can go 2 smaller, 2 larger. Now notice we already have 2 of the values
Yep.
from here. So that's good. Let's have you fill in the rest of this table, please.
Okay. -1, -2, 1, 2, 0, 0. Looking 1, 1 minus 2 times 1 plus 2, -2. And then -2 times 2 is -4. So I got -2 for -1, and then -2 for 1, and then -4 for 0.
Okay, so that I would have tried the 1 minus 2, 1 plus 2.
Oh, it's -3.
Yeah. So that's enough to graph it.
Yep.
I think graphing is kind of the most, it's kind of tedious here, especially if you've, once you know a little bit about technology and the availability of that, but they want you to graph it, so you need to graph it. That's fine. Okay. There's your graph. All right. So we have a lot of the information here from this table. We just have to be very, explicit. We have to say exactly what it is. So the vertex is at 0, -4. Actually move that closer to the actual vertex. Okay. We have the x-intercepts, 2, 0, -2, 0. The axis of symmetry comes from the vertex. So the axis of symmetry in this problem would be x equals 0. Last thing is the domain and the range. I can't remember if we've talked about this.
The domain is always all real numbers,
Yeah, everything, all real numbers.
and then
Uh,
range is y is greater than or equal to -4.
yeah, you got it. Okay.
So then y-intercepts.
The does not ask for the y-intercept,
Oh,
interestingly.
okay.
You
So
know, I don't,
just the x-intercepts?
I guess, but your teacher would really could ask for everything,
Yep.
reasonably. I mean, okay, so number 10 is really, really similar, just different numbers.
Okay.
So here we go, number 10. Again, probably best to find the intercepts first. So you set
Then
the x terms. This -4 is not an x term, just the x minus 7, just the x minus 3 equal to 0.
okay. So I'm just like writing all this stuff down. Okay, so then the x-intercepts are 7, 0, and 3, 0.
Good. So where does that put the vertex?
5.
Yeah, so your table, x and y, 5, and then we don't have that value, but 4 and
Yep.
3, but we have that one, thankfully. 6 and 7, got that one. So go ahead and carefully fill in the rest of the table, please.
Okay, so 3, 0, 7, 0. And 4, 5, 6. Okay, so then 4 plugged in. Okay. Where's my calculator? Then -4, parentheses, 4 minus 7 times 4 minus 3 is um, Oh, oops. Negative 4 minus 7 times 4 minus 3. So then 4 is 12.
Okay.
So then 12 for 4 and then 12 for 6. So then just plug in 5. And then 5 would be 16.
Okay. So this one's a little harder to get, that exact graph. I mean, I would be okay with kind of more of a, I don't know, approximation where, 516 is up here, 412, 612, 3070, something like that.
Uh,
Okay.
so then
And
I'll probably just like go by, I don't know, like 4s maybe.
right, I don't want to get hung up on graphing because there's a lot here, and I assume you know how to graph by this point reasonably
Yeah.
well. Okay. The stuff that matters is making sure you're consistent on all the other ones, which is the vertex, x-intercept, axis symmetry, and all that. So I guess you do have to graph it because you got to turn this in, but when you're done with that, let's have you give me those other values.
Okay. So then the vertex would be 516.
Okay.
The domain is always all real numbers. And range is y is less than or equal to 16.
Good. Missing x-intercepts and axis symmetry. Maybe
Oh,
maybe
yep.
you already said those, but
Okay. Let me write those down. So the axis of symmetry is x equals 5.
yes, that's right.
And then the x-intercepts are 7, 0, and 3, 0.
Yes. You said those early on, so I assume you got it. All
Okay.
right. Do you want us to do 12 or do you want to save that for later? It's up to you.
I think we could do 12.
Okay. So because it's in factored form, that's why you find the intercepts first.
Okay.
If it were not in factored form, you do something else first. I think that's the whole point of this section you're in, is to learn what to do with each form. Okay. So x minus 3 equals 0, x plus 4 equals 0, x equals 3, x equals minus 4.
Yep. So then it would be 3, 0, and minus 4, 0.
Yeah, now this one poses a slight problem, which is that the vertex is at an ugly, bad place. The vertex ends up being at -1/2.
Ooh.
Okay, so because it's the average of these x values. So
Yeah.
in terms of your table, you will have to evaluate it at -1/2.
Okay.
Okay, but you don't have to evaluate all the other ones at a half. Like you can go -1 and 0, -2 and 1. It's just the one that you have to do at that really bad, awful point.
Okay. So then -2, -1, -1/2, 0, 1. And then plug in -2. -2 times. -2 times -2 minus 3 times -2 plus 4.
Let me know what you get for -2.
So I got 20.
That's correct. I would suggest doing the positive ones in the zeros rather than the negatives. I know
Yeah, but
they're first
I'm
and
just
most.
I'm just plugging it into a calculator.
Oh, you are. Oh,
Yeah.
fantastic. Okay. All
So
right.
then do -1, and I got 24.
I believe that's right. I'm looking at the graph of it. Yeah, that's right. 24,
So then the 0.5.
negative 0.5. Just be
Yep.
careful on that.
Negative 0.5 minus 3 parentheses negative 0.5 plus 4. And then I got 24.5.
That's correct. Okay, very good. So from here, you can make that sketch. Again, I mean, it's gonna be hard to get this really to scale, but it's because your points are very much close to the together here. And I guess we've got 3,0 and or sorry 3,0 minus 4,0, something like that would probably do. And then from here you need the vertex, which you have,
Yep.
the axis of symmetry,
Okay.
the x-intercepts you just found already. And domain, it's really the range that's the most important one here.
Okay. Uh,
Any questions on that?
I don't think so.
Okay. We can move on to 14 whenever you're ready.
Okay.
So the next grouping of problems are all unfactored. And
Okay.
so the suggestion, the hint here is to factor.
Okay. Factor
And
it out first.
factor out a GCF.
Okay.
Okay, so why would you do this? Because then it looks like 8, 10, and 12. It looks like the 3 problems you just did. And then it's really just like 8, 10, and 12. You're going to first find the intercepts by setting the factors equal to 0.
Okay.
And what the nice thing there is that gives you the vertex. Vertex is right between those two. And then that tells you the other values you need in your table.
Okay.
Now you have a choice. You don't have to go to the factored form when you evaluate. Like I find it's easier to evaluate sometimes in the original, sometimes in the factored form. It just depends. It doesn't really matter as long as you get the right answer. You get some choices here when
Okay.
you do this. So go ahead and work those out. Let me know what you come up with.
Okay. And then 2. And 2 times 2 minus 8. So 2 is negative 12.
That's correct. Which means 1 is, I'm sorry, 6 is negative 12.
Okay. Then for 3, negative 15.
Okay, good.
And the same for 5. And then for 4, it's negative 16.
That is correct. Okay. So again, kind of a rough sketch. What does this look like? Always start with the vertex 4 minus 16. And then you got, points on either side, and then 2 like this. And we do know that it goes through 0 and 8. So you can get those in there.
0, 8. Right there. Right there. Right there. Okay, so then the axis of symmetry is equal to, so that x equals -16.
That's the X value,
Oh, oops. X equals 4.
right?
So then the vertex equals 4 -16.
Okay,
Domain is all real numbers.
okay. What about the range?
And the range is y is greater than or equal to -16.
Good.
And the x-intercepts are 0, 0, and 8, 0.
Good. It almost lends itself to a table of answers for every one of these, but that's kind of your call
Okay.
on that. All right, so 16. We'll do 16 next here. Do you normally
Okay.
get this much homework? Because this seems like a really long assignment you're
Yeah,
asking me.
actually, I usually do.
Wow, a lot here. So always, first type of factoring you always do is GCF, just like in the previous problem. What is the GCF between 3x squared and minus 48?
3.
3. So that's x squared minus 16. And because you're you're a ninja now at factoring, you're supposed to say, oh, that's difference of squares.
Yeah, x minus 4.
And now it's in factored form, so you can do exactly what we've been doing. You can set each of those factors, not the numerical value in front, the factors equal to 0, and get your 2 intercepts. And your vertex is right between them.
Okay. So then the vertex is 0, 0.
It's at 0. We don't know what the y value is yet. You go back to this equation
Oh,
or
yeah.
the factored form. Yeah, be careful. Jump to conclusions on that.
Okay. So then if you plug 0 in, so 0 minus 4 is -4 times +4 is 16, so -48.
Yep. I'd do the positive ones. Even if you got a calculator, just still be better, in my
And then
opinion.
-3 times 5 is -15. -45 for 1 and -1.
That's right. So you can see these are kind of tough to graph.
Yeah. It should still say graph them though, right?
Yeah, this one does. It is a graph. So it'll be a rough sketch.
Yeah. So then for -2, negative is negative. For 2, it's 2 and 6. That's 12, so it's like 36.
Okay. -36.
Yeah.
All right. And then again, graph here, it's just horrible, right? It's 0, 48, -1, 45, 1 minus 45, minus 2, 36. And eventually it does cross again, but it's
Yeah. And then so the axis of symmetry equals x equals 0.
that's right.
So then the uh, vertex equals 0, -48.
Okay, very good.
So then the domain equals all real numbers.
Yes, always all real numbers in these. Not much to change on those.
And then the range is y is greater than or equal to -48.
Yes.
And then the x-intercepts are 0, 4, or 4, 0, and -4, 0.
Okay. Very good. So I'm just looking ahead. There's just one more of these. The rest get a little bit faster. I think that's
Yep.
why so I was a little worried that we weren't going to get through all this, but your
Yeah.
teacher's trying to give you like one of each type of factoring that you could see. 18's another type of factoring that you're now an expert at. It's why they hit it so hard in the last unit. So you got to factor this two numbers that multiply to -27, but add
Now
up
this is
to,
in standard form, right?
right. And I would still factor it if you can.
So you
Because-
could do though, you could do the a equals,
Yes, but if it factors, you should factor it.
yeah. I don't think it factors though, because it's x squared. There's not a 3. Oh
So
wait, no, it's a wait.
so you're trying to find two numbers that multiply to -27, but add to +6.
Uh add to +6, -3 and 9.
Yes, so x plus 9, x -3.
18 x plus 9 x minus 3. So then that means for the table, um then
What is the vertex? What's the in between value?
there's -9 and 3. So then in between that is the average of 6, or no.
So an average, you add them up and
Yep.
divide by 2.
Oh, okay. So then it's -3.
Yes, it's very important to get that one because you can get where you think it's right, but it's not. So now it's up to you. You can use the standard form, you can use the factored form. Hopefully they're saying that in class, like you have a choice here which one you use
Yep.
for each of
Mm.
these.
So then 8 times -4 is -32. So then -1 is -32.
All right, let me just check that. That sounds right. And I was slow to graph this one. It does look right. Yeah, -32.
Okay. And then for -2, it'd be 7 times -5 is -35.
That's correct.
And then for -3, 6 times -6, -36.
Yes. So again, pretty extreme one here. Down here is -3, -36, -2, -35, -1, -4, -35. And then it does eventually hit at 3 and -9. Not the best, but if you're, if you've got good gridded paper, you can do a nice job, but I wouldn't get too obsessed over graphing unless your teacher really emphasizes it.
Yeah. So then the axis of symmetry is equal to x equals -3. Vertex is -3, -36. Then the domain is all real numbers. the range is y is greater than or equal to negative 36. And then the x-intercepts are negative 9, 0,
Got it?
and 3, 0.
Okay, really good. Okay, I'm glad we can move on because boy, these are there's so much they ask for. They're like 5 problems in one.
Yeah.
But the rest here should move a little faster. So 22 is to just find the zeros.
Oh,
And
so it's the opposite of what, so it'd be negative 5 and 1.
yeah, exactly. That's it. And 22. So 22 is not, I'm sorry, 24 is not factored.
So that means I have to factor it out and then figure it out, right?
If you can factor it, which they may or may not be factorable. But I believe this one is. So you should
Okay.
always try factoring if you can.
That one is not factorable.
So did you write all the factors?
Oh,
2,
and that's right. You have to do the
26.
multiply thing.
Yeah.
4 and 13. So negative 4 and negative 13
Yeah.
adds to be negative 7. Okay, so then x minus 4 and x minus 13.
Okay.
So then the zeros would be 4 and 13.
That's right.
Okay, 26.
Is 26 part of the same grouping? Yeah, it is. Okay. All right. So with 26, I get the snipped in. You want to do the GCF first, always the GCF.
Yep. It's always the GCF first.
So
So then
negative,
it'd be negative 4 x squared plus 2x
plus 1.
plus 1. Yeah.
Yeah. Good.
Then someone has to add to be 2. It multiplies to 1. So x and x. Or
Add
1 and 1. So
yeah, multiplies
x,
to 1, adds to 2.
so x plus 1 times x plus 1. So then the answer would be negative 1, negative 1.
Yeah, so what does that mean if it's the same number in terms of the graph?
It's like a double root, I think.
Yeah, so it actually bounces.
Yeah, it's when it has one x-intercept.
That's correct. Yeah. All right, 28 is not a quadratic. Why is 28 in this part of the book? That's really weird. Okay. So what you're supposed to see is that the first one is difference of squares.
What square? Oh, 30. Okay, so then it would be x minus 6 times x plus 6 times x minus 11.
Yes.
So that means it's a cubed root function.
It's a cubic, not a cube root. Cubic.
Oh, it's a cubic?
Cube root is something different. I mean, there's they're relationally kind of the same, but so you have to set each of these
Equal to 0.
equal to 0. So this one has 3 x-intercepts.
Yep. So then it'd be 6, negative 6, and 11. Okay. So then next one I think is 31.
31 through 36 all. Now the reason it's all is because there are 6 graphs. So this is almost like an SAT prep type of question. What I want you to do is look at 31 and figure out the x-intercepts of that.
Okay.
And then I'll snip in the other graphs. I know you got them in front of you, but you're basically just trying to figure out, well, which ones am I eliminating based on that?
So x-intercepts for 31 are -5 and -3.
Okay. So when you look at the graphs, I'm trying to get those in here. There we go. -5 and -3. I know they're kind of smaller to see. Like sometimes you can just eliminate, like that one's out.
So is D. It can't be D.
Uh,
Oh no, it could be D.
yeah,
It
I think
can't
it is.
be. It can't be C.
That's right. So that's enough here to eliminate
Every
it.
single one. So it has
Yeah,
to be D.
right. And this is how you approach a problem like this one. These are not good answers because they eliminate too many of them. But
Okay.
32, we can do the same way here.
Okay.
And just find the intercepts,
Okay.
and
So the
then
intercepts are -5 and 3.
okay. So again, we already, I don't remember, we know it's not D because we did that one.
Yep. So
So like
then it could be. It can't be C. It
that's
can't
right.
be A.
Yeah, A is kind of weird. It's -5 and -5.
Uh,
So it could be
it
E
can't
or
be B.
that's right. But it could be E
It
or
can't
F.
be F because that's.
So it
Oh
goes
wait,
by
yes, it
two.
could. Yeah.
Could be E, could be F. So now how are we going to decide between the two of these?
Find the vertex.
Actually, 1, 2, 3. So E is out. It's I know it's probably, if you're not looking at your screens.
Oh, I see. Yeah, because it's counting by twos.
Yeah. So it's definitely F
Okay.
in this case. So the rest are done similarly, we'll say.
Okay.
Which ones we got? Those two are out. Okay. So I think it's almost harder to do it through my screen than to just look at your zoomed in graphs.
Yeah.
So I'm trying to show these in a way that's, but same issue here. You got 5 and -3 as your intercepts.
Yep.
And if I go back and grab all 6 of them, which one satisfies this? We already know
So
that
it
D and
can't
F are
be
out.
D or F. So then the only other logical one would be uh probably A, I would say if I had to
So this is
guess.
2, 4, and 5. So that works. That works for
Oh,
the first
wait,
one.
A doesn't work.
A is out. Yeah.
C,
Yeah.
could C work?
C
Yeah, C
works.
could work.
C works.
Okay. And 34 X intercepts. So then it's 5 and 3.
So they have to both be positive, and obviously there's some that we can eliminate
Has to
already.
be B.
It has to be B, yeah. And when they're like both positive or both negative, or one on each side, that's another way to sort of eliminate certain answers.
Okay, and now one is -5 and 5. Has to be D. There's no other one that's completely negative. Oh wait, no.
We've already done D.
Yeah. We've done D, E, F, and C. I think we've done E. Have we done? No, we've done D, F, C, and B. D, F, C, and B.
Okay, so it's down to A or E.
Uh, it looks like it would be A.
Yeah, I agree. And then by process of elimination,
It would have to be E.
the last one is E. Okay, that's good. Now 38 through 42.
It should be even though, right?
That's right. Use zeros to graph the function. So we've kind of already done this. These are in some ways easier than what we've been doing because there's less things that are required. So notice 38's already in factored form,
Yep.
which
So
makes it
then-
easy to find the zeros.
Yeah, so zeros. Okay. So then zeros are equal to -1 and -7.
Good.
So then
So where is the vertex
just
between?
so it's between -1 and -7 and -4.
Okay, very good. Now the way the problem reads, this would be the correct graph. I think that's all they want, but your teacher wants you to build a table. So you probably should. I'm not sure.
Yeah. Yeah, so I can build a table of 3 values, like, she wouldn't mind that.
Okay,
So the -4, so then just plug in -4 because we already know -1 and -7. That's really all the points I need.
okay, that's good.
So then, that would be 3 or -3 times 3 is -9, so -27.
It's positive,
Oh, yeah. Oh, yeah.
positive. Yeah. So is that sufficient? Can we go on to 40 or is there more to do?
Yeah, no, that's good.
Okay. All right, so go ahead and factor this one, please.
Okay, so then 39 or 40. Factors would be so it has to multiply to -30 and add up to 1. 6 and 5, so then 6 and -5, so x minus 6 or x minus 5 times x plus. Oh, wait, no, I was
So
right the first time.
your signs are off because it's got to add up to
Yeah.
-1.
Yep. So then x plus or plus 5, yep. X minus 6. Okay, so then plot 5
So
and -6.
yeah, so where is the vertex? This one's not so
So
good.
it's between sounds like it would be 1/2. I feel like it would be
Yes,
1/2.
it is 1/2. Yeah, and it's not a great number, but that
Yep.
is a key point to graph. So you
Yep.
said you had a calculator, so just
Yep. Okay. So parentheses 0.5 minus 6 close parentheses 0.5 plus 5. -30 and 1/4.
okay. So that should be sufficient to get the graph.
Yep. So then it opens up or it opens down. Or no, it opens up. Yeah.
Yeah, and your points should confirm that. Like you should make a note right from there that it opens up because A is the leading term is positive.
Yep. And then number 42.
Yeah, so again, factor GCF first as always.
Okay. So I'm just looking at the problems really fast.
So that's x squared minus 1, and then x minus 1, x plus 1.
Sorry, what?
So
Oh, you
difference
just
of
factored
squares.
it.
Yeah,
Yeah.
difference of squares. Just want to make sure we get through as many as we can. Actually, won't be too bad to be able to do this.
Now we only have 2 more problems left, I think. So then it would be 1 and then -1 would be the thing. So then the middle would be 0.
That's right.
So
And then
then 0 minus 8 is -8.
yes, there's your vertex. And this opens up because the A is positive.
Yep.
So that's this one's not too bad to graph.
Yep.
Okay, 64 really quick. We got to make sure we get these done. You're finding intercepts, so you're just setting these equal to 0. So
So
there's
then it'd be so x intercepts. You have -1,
4 and 5.
5 and 4.
Yeah, so this one you need to know a little bit more to be able to do.
Yeah,
It's
so it'd be up and then down and then back up. Yeah.
yeah.
Does it ask to graph it?
It does. I
Okay.
don't know how you're supposed to know how to do that, but because you guys have barely covered this, but it's coming up. All right, so the next one here, you want to factor out the GCF, which is -2x. That gives you x squared minus 10x plus 25. And this becomes x minus 5 times x minus 5.
Okay. And then that's just a normal graph.
Yeah, now because it touches, that's a little bit of a difference than you've seen before. So it actually starts coming the other direction. It's negative, and then it bounces and goes back down.
Okay.
And there's more to that than I'm telling you, but that's I mean, the limited time we've got, we'll just have to go with it for now. It
Okay.
sounds like you're moving into polynomials.
Yeah,
pretty quick.
we've done polynomials before, but I don't think we've ever graphed them.
All right. Well, does this mean you're done with your math homework for tonight?
Yes, I think so. And then I don't even have math tomorrow.
Excellent. Excellent. All right. Well, let me just stop the recording here.